Sir, we'll wait for 5 minutes. At 6:05 we can start.
How much time? What time should I start, sir?
After 5 minutes we can start. Just when
Yes,
the
sir. Yes, sir.
participant more about maybe 70 or 80, we can start. Within 5 minutes they will join.
Okay, sir. By 6:10 I will start, sir.
Okay, sir. Thank you, sir.
Okay, sir. Thank you.
Avi.
Hello, good evening, friends. Today is the second day of our presentation. Hope you have enjoyed your first day session with a lot of enthusiasm. You have all participated. I'm very happy for that. And what we will be doing in this session, first I will summarize what we have discussed yesterday in the first session, and then I will be joined by my student Atal Fdp, who is also pursuing the computer science software engineering from Ajinkaya DY Patil University. He will be explaining his project. He is also working with a lot of DRDO projects and all that parallelly. He has a separate lab established for the machine learning and all these aspects in our School of Engineering itself. And later on, we have a concluding remarks by Professor Pushpu Trivedi Madam in the last, but I think another 2-3 minutes we will start the session. And you have any further doubts in the machine learning, AI, IoT, cloud, and its integration? You can ask me, friends, for the next 3 or 4 minutes. I'll be able to answer your doubts. The doubts may be of any complexity or even simple or silly. Probably there is no there is no problem with me. You can ask, my friends. I will discuss for the next 2-3 minutes until all the people join. We will start by 6:10. We have 4 minutes left over. My dear friends, please unmute yourself and ask some doubts so that I can clarify you. Please, my dear friends. Anyone? Please.
Sir, before starting the session, I just welcome you back again our Atal online FDP session, and it's a immense pleasure that you again come back to your original track. So
yes, sir.
All of you from the participant side and Aryan side, I am extending a warm welcome to Dr.
Thank you,
Ganesh,
sir.
sir.
Thank you. But
all,
it is
all
a hectic day for me, sir.
Yes, sir. Yes, sir. I know, sir. I know, sir. Only you.
It is a
you
hectic
can do
day
this.
for me. It is a hectic day for me. All over from night 11 o'clock, I am traveling. I just reached home at 5 o'clock. Tirupati is my hometown. And I got freshed up, had some brunch, and I got sat down for the session. But I think the applause from the audience is the best energy that I can get.
Yes, sir. Yes, sir. Everyone is expecting that the sir will giving some new idea, or new concept, or new things will be there. You are so interactive with your audience. So please, audience, if anyone having any interaction with sir, can do.
Please, any research problem you are having, you want to discuss, you can please tell me. I can guide from the knowledge that I have acquired for the last 5 years. I'm working like a double PhD on this area because I found it interesting. Whenever you find it interesting, you will not feel any toughness in that particular field. That is my motto. And my another motto is update and upgrade so that you will not become obsolete. That is my own caption. That is not written by anybody. I have written it myself. For my career, how it has been shaped. Even in at the age of 52, I continuously work for daily 12 to 14 hours. I continuously work in search of the new technologies, how to deliver the products to the students in the most simplest, lucid way. Work in groups with my students and the co-professors. And basically, I have to tell you, I am from a mechanical background. I don't have anything to do with computer science or electronics and all these particular things. But having come to this way, this long, people recognize me as a computer science engineer, and they also recognize me as a electronics and communication engineer. So I am very proud that I have eliminated these boundaries or domains in these particular engineering branches successfully. So it's almost 6:10. Shall I start the session, sir?
Yes, sir. Yes, sir. Yes, sir. Continue.
Okay, sir. Okay. My dear friends, so Adarva, have you joined? So how I will be taking this session is that I will be continuing for another 10 minutes or 15 minutes. I'm giving you the brief conclusion, outlook of what we have discussed yesterday. And my student Adarva Saraf will be taking the charge of this session, and he will be projecting his this thing that I already told you. Finally, Professor Kushbu Trivedi Madam will be giving the concluding remarks. Then again, I will come back before we'll be answering your questions. With three will be answering your questions for this session ending and all this during this session ending. So, see what is the impact of this session. 18 numbers within 4 minutes. It has reached to 1 or 2. I think in another 5 minutes it will reach to 200. That's a positive indication that people are really liking this session. Okay, Adar, are you there? Kindly unmute and say hi to me.
Adar? Yes, sir, I am here. Whenever you are ready, sir,
yeah,
I will take over.
Yes. Thank you, Adar. Thank you. You are there. Okay, then. So, my dear friends, you should try to understand whatever this machine learning and AI, IoT, cloud that is coming up, my dear friends, it's not a quantum mechanics or something hypothetical, something very high which cannot be perceived by us. Anybody, everybody and anybody can happily take up this new technologies and try it out, my friends. It's very simple. There is nothing that, but only problem you might be facing probably as an electronics engineer is the problem in coding. Some people might be in the computer science background. They might be facing the electronics hardware deficiency. And I don't think any mechanical or civil people have attended from long. Whenever I went for the training in this computer programming, Python, embedded systems and all that, I used to find, I used to go and attend with the students for the weekend sessions at Aiet Madras in way back in 2022. I was the only mechanical person. Unfortunately, nobody used to be there. That is the brought up, our mindset is brought up that mechanical means you should study only mechanical. That's not the case, my dear friends. We have a lot of potential. Recently, I have interacted with a computer science engineer, software engineer, working in Boeing. He is working on machine learning and predictive model development for the Boeing. Given the data sets of its efficiency, its fuel efficiency, its number of hours, and all these things, very large data sets, around 10,000 hours, my dear friends. We cannot decode that. Only the neural networks and all these things, softwares and high processing speed processors will be able to do the machine learning models. He does the predicting of expecting the, giving the outcome of how long will this aircraft can fly safely with this set, with these parameters. Really, and I would like to remind you, my friends, AI and ML is nothing, my friends. ML is nothing but just a data set. That's all. It's nothing but data. Data in the form of structure. That is whatever I have shown in the form of an array. I have shown you data in the form of data set. That is in the form of array. Or data can be in the form of unstructured, in the form of images and all that I have shown you in the yesterday's session. Okay, the curtain is somewhat disturbing, I think. Okay, no problem. I can change the background. I will just see. Open picture, background and effects. Yes, I have some backgrounds also. So I will put some background, my dear friends, so that it can be stable. Yes. Okay. But still the camera is somewhat moving. Okay, don't worry. I think this is very, this thing, okay, Let me switch over to this. Yeah, it's fine. Okay. So here, what we are having, my dear friends, yeah, data. AI means nothing but data set. That's all. AI, we are having machine learning. We are inputting that machine learning data set into the Google Colab or some softwares like that. And if it is an image, we are using the YOLO. You only live once. That is the meaning of YOLO. That will be explained by Adar and all that, and the Kushbu madam, Professor Kushbu madam. So how do we develop the data sets and all these things? So primarily, we'll be studying the data sets of agricultural disease detection, and also the other one is the flood disaster management. These two things we'll be discussing, my dear friends. So I will close this background. Let's close this, right? Okay. So that I'll be doing it. So here, my dear friends, so AI means what we are trying to do. We are trying to mimic the human intelligence, and we are going to load it in the microcontroller, so that microcontroller, how we are going to arrive at AI with the help of machine learning. AI is a broader perspective. Machine learning is the circle of the AI, and inside you have the deep learning. Both machine learning and deep learning use the neural networks for processing the data sets. It's very used data set, my dear friends. I have once used Power BI for the data set of students, 10th grade students of UK. Some 10,000 students, my dear friends. Within 5 minutes, it has given some inferences. I have selected X and Y coordinates. For example, income group of the parents, grades obtained by the students, and it's a 5-year continuous data set, my dear friends. And how beautifully the lower income group parents, students have successfully got good jobs, high paying jobs and all that. There are inferences, my dear friends. That is what we get from the data set, the inferences. That is how the weights and bias are being assessed by this Google Colab, by using the graphic processing units and all that. That is how precisely in any crop disease, precisely just give the leaf drone will capture the leaves of that particular surrounding area, and it will detect what stage of disease is there, what stage of crop is there. I know one of my Instagram follower, Kavya Koppavarapu, she is a Harvard medical student. She, after completing +2 in US, she has discontinued for 1 year, and she belongs to Tamil Nadu. She came to Madurai and Aravinda Eye Clinic and all. She collected a lot of eye images of diabetic retinopathy. That is a disease which diabetic patients will lose progressive degradation of the sight over the period of time. She analyzed by using this data set, machine learning model she developed, and finally, if you scan your eyeball, that image by your camera, that software, that app, then it will detect is there any diabetic retinopathy, what stage it is, what is the that is the first app created in the world which can diagnose diabetic retinopathy, my dear friends. She is a 12th standard girl. She is immediately offered her app. She sold to some third party, private party for a number of millions of dollars. She got a scholarship from Harvard Medical School. She completed that also. Later on, nowadays, due to my busy schedule, I could not follow up her. This is the potential of AI, ML, IoT, cloud, and all these particular ideas, my dear friends. Now, so I have told you this AI also. So whatever the deficiency that I am coming to the point, wherever we are feeling generative AI apps are there, my dear friends. Today, wherever we feel deficiency in the particular branch, for example, mechanical, I might not be an expert in the coding as well as the hardware technology. So I use it. And over the period of last 2 years, where I have been working as adjunct professor in Pune, by the help of the students, I have developed some precise selective prompts where I could get the appropriate things that are required to me by the ChatGPT, my dear friends. This is astonishing, really. And I just copy that again. I give it if there is some errors, there is some debugging supposed to be done. Lot of things that I give it. Immediately it will respond and it will give the updated code and requirements that are to be done. And really, over the period of last 2 years, I've significantly advanced with the help of generative AI. That the process of advancement it can be easily comparable to another 5 to 10 years of my work, which probably around my retirement and 60 or 65, I could have reached. I could have. I am. I am happy to say that the 10 years of long duration of progress I had accompanied in the 2 years with the help of this generative AI applications, my dear friends. Please make a part and participle in whatever the way of box of life that you are there. Generative AI to incorporate in your regular research curriculum schedule, as well as the teaching curriculum, teaching schedule, updation of the syllabus, and delivery of the content to the students. Definitely, you are going to get a lot of advantage with these friends. Now, since I have given a complete overview of that, so seamlessly this can be integrated with IoT AI. Drones, everything is nothing but IoT only, my friends. We'll have one more session on the IoT, basics of IoT, advancements of IoT, IoT connectivity with AI and cloud, how beautifully we can connect. That we can have separately one more session somewhere we can join, or you can also call me to your college. I will come with all the kits. I have developed so many kits. I will come with the kits and all. It's a nominal fees. I'm not working for any commercial gains in this particular field. It's a nominal price. I will come to your college with all the kits. I will give the training to your students and all these particular things, my dear friends. Okay, so don't worry. I will be in contact with you in the WhatsApp also, so don't worry. So now I request my student Adarva to take over. Adarva, you can take over.
Yes, sir. Sure, sir. So let me just present my screen so we can look at what we are going to deal today.
Yeah.
So I hope my screen is visible to everybody.
Yes.
Yes, sir. Yes, sir. Yes.
So I will say very thank you for joining this whole session. We are having 120 viewers, which is very astonishing for me. So I think Ganesh sir have already explained what our project is, but I will give you a very brief overview of what we are doing. We are trying to regularize the agricultural flow of our India. As you know, Indians, we still have our economy very based on the agriculture. We have the biggest population, and we have the whole indigenous agriculture farm. We don't import any type of food, which is very I think say astonishing field. And this agriculture field is still very underdeveloped. Many of the farmers, as many researchers show, still grows food in a very traditional way, which causes like 40 to 50% of their food to be lost. I will show you the whole research and data where this numbers came from. So our idea is to build an ML level algorithm, which we will be integrating with unmanned aerial vehicle, which is UAVs or drones. So the main feature is that the UAVs actually provides the very high solution for moving farmers from one place to another. So for example, if you have a very big land, acres and acres of land, so managing the whole farm area is very difficult. Knowing which plant and which crop have got disease or cause any type of you can say malnourished can be very difficult for the farmers. Using the traditional methods actually causes issues. We will talk about that as well. Like I said, the global the trade of plants or you can say crops reduced to 40% because of the diseases and the other type of losses that is caused by this whole affection to the crops. The 40% of the production of the global is caused by, which equivalent to $220 billion of trade, which is lost every single year. This goes up to 10.3 billion in 2021. The data is very well equivalent in the farmings of UN SDGs, the goal number 3, which is no poverty goal. It shows the data in very clear way. The secondary, you can say, options that we have are the traditional options, which are being used by the farmers. They are very inefficient and you can say very irregular in their own cases, as having an acres and acres of the land can cause farmers to have high amount of labors and have many lab testings. For example, if you take soil and data from one area, the other areas can have different results in 1 or 2 years, which is very hard to track and very hard to maintain. The easiest way to know whether any crop on a plant have any disease or any malnourishment is looking at the leaves. This is a very efficient way, as every plant or every tree shows in symptoms on their leaves. That's the most you can say sensitive part of their whole structure. Well, the problem comes with the traditional method is that we can't look at every plant and every crop. You can imagine we have thousands and thousands of crops in just 1 acre of the land, and which makes this whole process very efficient for a human. So either you have to employ many labors which have to be trained on what symptoms look like on the plants and the leaves, or either you need computer visions. This is where our whole projects comes into play. We are planning to deploy drones which can have aerial imagery of the whole land, the farmland, and then it can analyze the whole image and predict which tree or which plants have any type of disease based on their leaves and the behavior of how the leaves causes. This is done by a ML feature, which is a machine learning feature.
At precise location also. At precise location.
And the precise location also. So there are two ways to get this information, either from the aerial shot, which shows the whole upper view of the trees, and then the AI/ML, the machine learning algorithm can detect whether any tree have any type of diseases, or even overwatering and underwatering can cause harm to this crops, which is also known as high level or high ground imagery. Other is having close-up shots from the ground, or from having our drone coming too close to the plants and having shots from each crop and trees, and then moving forward in the line, having an automatic grading system which can tells you about how a crop and how a health of the crop and plant is doing in a very efficient way, because this is a whole automatic system. So for the imagery, we are using a CNN based system, which is a convolutional neural network, which actually takes image as their inputs and predicts whether image has a true value or a false value. In our case, the true value is a healthy image or healthy leaf, and false value is any type of disease that that plant can have, whether it is black rod or malnourished, whether from having lack of waters or a lack of nitrogen in the soil, or whether this is overnourished, having lots of water, which can also cause harm to smaller plants. So this shows you the whole overview of what the systems look like. Currently, I am only focusing on the pre-processing and the main machine learning algorithm. The pre-processing works with the raw image. As you can imagine, any drone capturing image from a higher altitude can cause that image to be blurry or sometimes even distorted because of the turbulence the drone can have. This image processing or the pre-processing eliminates that feature and enhance the image based on what type of information we need, either focusing on a single part of a image which can contain 1 or 2 trees, or either focus on the whole image depending on what type of prediction system we want. Generally, the approach is to have a 5 trees by 5 trees in a row, and have a have you can say a rectangular image, square image, which is 224 by 224 pixels, which gives you a very high ratio of working on the image and very high resolution, which neither takes high processing power and space in your memory, or neither it's too blurry or too small to do any processing on it. As this shows that this algorithm or this approach has the future of farming. Many you can say countries or many civilizations have moved to modern farming. For example, UK or US, as their farming equipment are mainly very high tech. They are, I think I have seen many images from the US where they are using planes and the helicopters to spread fertilizers and pesticides over their big farmlands. Whereas still in India, we are using tractors, which causes harm to the crops inside as tractor leaves their marks, which causes the crop to become either damaged or either get diseases from the tracks of the tractors and the trucks that we use. And this is how the image is processed. Computer takes a real image, then convert it into a black and white image to have, you can say, every pixel represent either 1 or 0. The 0 showcase the white color in here as it's turned off, and the 1 showcase the black color here. Then converts that whole image into a erosion and then marks the outline. This gives the computer the overview of where the data will be contained. As you can see, this area, the outside area, that's what we call an offside. And offside is something which is a black color, which have the pixels in it, but computer generally ignores that image. And then comes the edge. The edge shows the computer that after this edge, we have the pixels and the data that is very important to us, and then it will read it. The inner part is what we call an inset. An inset is generally what we need as in you can say processing. A computer takes every color and every color in that pixel and then combine it with the whole scenario. For example, if we have an image like this one, you will see it's not a constant color. It has a changing gradient. It has a changing lines. The colors are being changing, but they change in a very particular way. The central of the leaves represents their you can say branch, and that branch usually is the major change in the color in that whole image, and other than that there's nothing. But if you look at this image, you will see two sets of leaves. The one is a healthy leaf, which is on the left, and the one is a black rot tree. It's like of disease that is caused on the apple trees or trees that usually have fruits on them, usually caused by fungus or bacterial infection, and those are marked by the pigments or the spots. These are the spots or these are the patterns that a computer usually detects. It can either be a completely black leaf, which showcase the you can say high density of sunlight absorbed by a tree, or a completely you can say fade out leaves, which showcase the less density which provided by the sun, which means the tree usually needs more sunlight than it is getting. But the pigment shows that this whole area is getting infected by the fungus or the bacteria, and this is what the pattern that we are looking for. If you see even a single tree getting this type of infection, generally the whole area gets the infection as a whole. So this is a very easy for a aerial shot to detect. If you are in the high in the area and you have like 500 by 500 of the grid and you spot a single tree having this type of infection, there's a high chance that this infection is caused to 5 by 5 area of the grid. So that's why the whole detection system works in a aerial perspective or in using drones. So in CNN, there are 3 layers that we use to detect this whole patterns. The first is a convocation layer where we makes out the grid, makes out the edges, and then we takes the color into it. Then comes the pooling area where the more computation and the memories are used to detect which color and which patterns are in. Then we connect all the layers, these 2 layers, to create a fully connected layer. And this layer synchronizes the high level of understanding and then give off the prediction. I do have a single simple, you can say, algorithm which runs on 100 data set images, 100 images, to showcase what this whole process look like. So just give me a second. I will present it. Okay. So this is the source code, which is a small representation of what the algorithm that we are going to use in a system. This source code takes constant image from apple tree and then clarify whether that apple tree has DCs or not. So basically what we are using a CNN based system which runs on a TensorFlow image. So the main objective of this whole algorithm is to detect the accuracy should be more than 80%, and it should have to detect whether the image that we give it is healthy or not. So that's why this part shows you the whole data transformation, as a single image can't be directly understood by a computer. A computer only understands a binary language, either it's 0, either it's 1. So image can't be directly put into any algorithms, and then the algorithms can't predict it. It has to be converted. That's what we call pre-processing. The pre-processing usually converts data, so it is suitable for any algorithm, whether it's DL based algorithm or machine learning based algorithm, for it to understand and then perform various type of functions on it, so it can predict the data. In pre-processing, the general way for images is to convert the whole image into a you can say single format, like having all the images in the same type. So for that, first thing we do is we eliminate any corrupted images or any images which is either too small or either too big. And after that, we resize all the images in a 224 by 224 pixels. So the reason